Okay, in the last part of section 3, we're going to look at how we can use molarity in our A to B stoichiometry problems that we've been doing all year. So, first of all, we learned the whole mass to moles to moles to mass problem. That was part of chapter 9. We also dealt with volume and moles for gases as part of chapter 11. Well, now we have a volume to moles calculation for liquids, or more specifically, solutions. So, how do we go from volume to moles or moles to volume of a liquid solution? First of all, we're going to use molarity, but it's a conversion factor, so we never start with it as a conversion factor. If we need to jump into this mass moles moles mass problem, here's what it is. Here's how a problem would be. It might say we get out a bottle and we pour out 825 milliliters of a 2.2 molar sulfuric acid solution. All right? And we need to figure out how many moles or how many grams of whatever we need. Well, remember here what the definition of molarity is. 2.2 molar means if we pour out 1 liter, if 1 liter, we're going to get 2.2 moles. But we're only pouring out 825 milliliters. Therefore, we're going to get a little bit less than 2.2 moles. So how do we actually show that? Well, here's one way, right? How many moles are in 0.825 liters if there are 2.2 moles in every 1 liter? Oh, we don't want to cross multiply and divide anymore. So what do we've got? We've got a new conversion factor, 2.2 moles for every 1 liter. And that's what we're going to use for all these calculations. So if we need to get a mole number, we take the volume and we multiply by the molarity. And we are off on our way. So in this problem here, we have 0.825 liters times 2.2 moles for 1 liter. And when we calculate this out, we get 1.8 moles of H2SO4. Now we're on our way to whatever other number calculation we need to do. Okay? So again, we took a volume, and we took a conversion factor, and we were able to find another number that we needed. Okay, so here's a problem here. We've got, and again, this is number 24 on page 427, just as a reference here. We've got 0.750 liters of a 6 molar solution. That's chemical A. And they want us to find out the mass of chemical B. So actually we've got two problems. We've got, there's our first, there's our second. How many grams of each product will be formed? So here's what we got. We got the volume of H3PO4. We need to change to its moles. Then we need to change to the moles of calcium phosphate and then the mass, or water for both problems, right? So moles of A to moles of B, that's easy. B over A. Moles of B to mass of B, molar mass of B, that's easy. Well, how do we go from volume of A to moles of A? Well, we're dealing with a solution, so we use molarity. How many moles per 1 liter? Here's our conversion factor. So we use molarity just like we use molar mass. And we solve our problem. So what would we do here? We would take 0.750 liters of H3PO4 times 6.00 moles per liter times B over A. I'll do calcium phosphate first, times 1 over 2 times the molar mass of Ca3PO4. And there's our answer. If we're doing water, it's exactly the same thing, except now B over A is going to be 6 over 2 times the molar mass of water. So that's how we do the problem. It's just a new conversion factor for us to use to solve some problems. give you another one here, and both of these can be show me's. Here we've got, we need to find out the molarity of this silver nitrate. So here's our chemical A. We have 0.250 grams of chemical A, and we're trying to find what was the molarity of B that we needed to use. Okay? So here's our step. Mass of A to moles of A to moles of silver nitrate. So once you have moles of silver nitrate, you now then have all the information that you need. You have the moles of silver nitrate from the silver. You also have the volume of silver nitrate from the question. Moles from calculation, volume from question. Now you can calculate a molarity, which is simply the moles of the chemical divided by the volume of the chemical. The last part of section 3 we're going to talk about is dilutions. Dilution is just a simple way to calculate a change in a chemical's molarity. We have a certain amount of a chemical with a certain molarity, and then we dilute it to something else and being able to calculate the changes. So it's a pretty simple calculation. M1 times V1 equals M2 times V2, where M is the molarity. So here's an example. Let's say I want to take 10 molar HCl, okay, fairly concentrated, and I want to dilute it down to 5 molar, and I want to make 500 milliliters of it. So what am I going to do to figure this out? Well, if we just kind of process it in our heads, I need to take 10 molar down to 5. So I need to take an amount of 10 molar and add an equal amount of water to get it to 5, right? To get 10 down to 5, I need to add an equal amount of water to get twice the volume. So if I need to get to 500 of 5, what I'm going to need is to take 250 milliliters of 10 molar and add to it 250 milliliters of water, right? So I go from 250 to 500 in terms of volume, right? 250, double the water. Now I have twice as much water, half as much strength. That's what we can do in our head. Problem is, it's not always going to be that nice and neat, because once we have various numbers and things like that. So it doesn't matter what 1 or 2 is, you just set it up. So what we could do is we could simply say, I want to take, so M1 times V1 equals M2 times V2. I'm going to take 10 molar, and I don't know how much I need, but I'm going to get it to be 5 molar, and I need half a liter of it. There's my calculation. 5 times 0.5 divided by 10, x equals 0.250 liters. Now, here's where you got to know what the answer means. 0.25 liters of HCl plus enough water to make 500. Okay, so this one's nice and easy. I 250 of acid, I an equal amount of water, and that becomes my half molar. Again, not a calculation for a reaction, but just a dilution problem. Now, here's another one. What volume of 1 molar can be made from 125 milliliters of 4 molar? So M1 times V1 equals M2 times V2. Again, it doesn't matter what's one or what's the other. How much of 1 molar can I make from 4 molar and 0.125 liters? I could leave it in milliliters, but it doesn't matter. So I want to figure out here what my value is here. We can actually say, well, V1 is going to be equal to 0.500 liters. So what that's saying is I can make 500 milliliters of 1 molar of this chemical. So what does that really mean? That means 0.125 liters of 4 molar, and then 0.375 liters of water. And that's how we get 0.500 liters. So you got to just be careful. This is one of those calculations where it's an easy calculation, but if you're not paying attention to what the numbers mean, you may be getting a wrong answer. Okay? So we get a couple of those pop up. Again, it's not a big concept, but it's a nice little thing to know if you run across it. All right, so that's it then for chapter 12.